Hello everyone, myself B. Siva Department of Electrical and Electronical Engineering from Upcoslunk Engineering College. My project title is Development of 9-level inverter with reduced device count and its fault tolerance variant, guided by Mr. B. Sakti Sudasan. A 9-level inverter consists of 16 switches. I have reduced it to 8 switches by using an LDN capacitor. This is my main circuit. I have designed it with 8 switches. By summing up the voltage sources and the capacitor voltage, we can get the 9 levels. If you give the VDC1 and VDC2 as 100, then the VDC will be 50 initially for producing the 0 voltage. This is the switching sequence. After that, I have produced VDC by 2, VDC, 3 VDC by 2 and 2 VDC. This is for positive cycle, and the negative vice versa I have produced it. This is the VDC by 2 output. This is VDC output. This is 3 VDC by 2. I add the VDC2 and VC. This is the 2 VDC. After that, I have designed for negative cycle. This is minus VDC by 2. VDC1 equal to minus 100 because I have connected the negative to the load. So minus 100. After that, VC will be 50. Adding minus 100 and 50, we got minus 50. Minus VDC by 2. This is minus VDC. This is minus 3 VDC by 2. This is minus 2 VDC. These are the levels. So this is my MATLAB circuit. I have designed a gate driver circuit by using the SPWM technique. Initially, I have compared a sine wave with a carrier wave for producing 5 output, comparing comparative output. This is depend on the level. Consider n level inverter. For that, n plus 1 by 2 will be the comparing parameters. I have taken a sine wave and then I give it to an absolute value, and then I compared it with the carrier wave. The carrier frequency is 4 kilohertz. Then the gate frequency is also 4 kilohertz. Um, Here I have done the comparison, of sine wave and the carrier frequency. After that, I got 5 comparative outputs. I have named it as C1, C2, C3, C4 and Z. By using these 5 parameters, I got the switching frequencies. Here I have dumped my code for producing the output for each switches. After that, I got the switching frequencies, and then um, the LDN capacitor initially get charged and settle in 50 volts. Here I have used 100 volts, and so I got 50 volts for the capacitor. And then it will produce the output, 9 level output. Here I have used an inductive load, and so the current is sine wave. Inductor does not allow the sudden changing current, so I got the current wave like this. If you modify to one resistive load, then the voltage and the current will be in same level. After that, I am going to do an FFT analysis. Um, the start time will be 8. I taking up to 10 cycles. I have given 50 as a input frequency, so I change it to 50 and then F50 compute. The F50 analysis I got. After that, I have designed the fault tolerance circuit. This is my fault tolerance circuit. In that, for a switch 1 and switch 2, I have given SRB1 and SRB2. For surpassing the fault occur in these four switches, I have given the SRB3 and SRB4. If a fault occur in S7 and S8, the capacitor should be separated from the circuit, and so I have used an ideal switch or an bidirectional switch. If a fault occurs in seventh switch, then this will be acts, and I can surpass this part. If you consider a fault occur in this S7, then you can't produce 9 level. Basically, some fault can surpass, like if a fault occur in an S1 switch, we can use SRB1 and produce the 9 level output. But if a fault occur in S7, you can't use the VC voltage, and so a 5 level only occurred. If a fault occurring in S3, we can surpass it using SRB3, and so we got 7 level. These three switches are critical switches. If a fault occurs in this switch, we need to bypass this whole part, so we can produce only 5 level output. If a fault occurs in multiple switches like S1, S4, and S7, then we can only produce 3 level output. That's all.